LiquidScore is a 3D interactive music visualization and improvisational performance system. Instead of using a physical game controller for input, a musical performer uses the pitch and amplitude of their instrument to control the system. An explanation of the system's behavior and mechanics follows. Playing two notes consecutively connects them. If a new note is played that doesn't exist yet in the graph, it will be created and connected to the previous note. If it already exists, it will simply be connected. The motion and structure of the graph arises based on a combination of a few simple rules. First, all notes repel each other. Second, all note connection lines behave in a spring-like manner. Third, all notes are pulled downward toward the ground. By summing all of these forces for every note, the graph is pulled towards some structurally stable state. Audio, pitch, and amplitude tracking is performed in Max MSP, a visual programming environment for audio. The performer's live audio input is recorded, parsed, and indexed by pitch value, so that segments of the audio recording can be associated with each note. All sounds made by the computer are comprised of these samples of the performer's input, played through a custom granular synthesis engine. Control messages are sent back and forth from Max MSP to the visualization software using the Open Sound Control protocol. The note the performer is currently playing triggers audio to be played back from each note it is connected to in the graph. Therefore, a note that is a hub of many connections will sound a more complicated chord than a note with few or no connections. The graphics are written using OpenGL and C++ with GLSL shaders. Some of the graphics features implemented for LiquidScore are custom 3D geometry for all shapes, including staff lines, note heads, and accidentals, a custom pseudo-physics implementation for spring-like connections and avoidances, smooth camera motions that automatically track the player's motion through the graph, custom shaders implementing a cartoon version of the Phong reflection model using outlines calculated from vertex normals, and full-screen anti-aliasing performed by rendering the scene at 3 times the actual size in each dimension, then averaging pixel colors with a custom downsampling shader. Rather than create LiquidScore as either a computer game or a musical composition, I sought to combine many of the best elements of both worlds. As a real-time audio-visual improvisation environment, it provides multimodal feedback to the improvising musician and encourages non-linearity and performer choice. It is a platform that is truly interactive and controllable while remaining musically readable and meaningful to both trained musicians and uninitiated audience members.